All right, let's rock and roll. Okay, here we go. We have this h of x function. It's composed of three parts. The domain breakup at -1 and at 1, right? So they give us this function h of x, and then they say, is h continuous at x equals 1 if a equals 3 and b equals -3, justify? Well, first of all, people look at this problem and they start freaking out. Oh, it's a piecewise function. I don't know what to do. Oh my gosh, what do I do? Oh, this sucks. What I like to do, and I do a lot of times, I glance at the function. I don't get emotionally invested in it. Just look at it. Oh, it's h of x, piecewise function. There's some variables in there. They're probably going to tell me what the variables are, and I'm going to have to do something with the piecewise function, right? These problems they get pretty predictable the more we do them, and that's a good thing. Okay. Later on, I'll give you guys problems. I'll put a function up there. I'll say, tell me what we could ask based on the problem that's given to you. What question would they not ask and why? That's important. Okay. I look at the function and then I look at the question. Is h continuous? Then I stop and I think, what does it mean to be continuous? Well, what do we know if a function is continuous? And what do I say in calculus? Always go back to your rules, your regulations, your theorems, right? When is a function continuous? If what? Points defined, okay. So it's a three-part thing we have, right? We know it. There's a three-part thing we have. So then what we do is we just go through that process, okay? The function has to be defined at x equals 1. The limit has to exist at x equals 1. And the function height has to equal the limit, right? Well, Mr. Bond, there's a's and b's. Substitute them in. What I like to do is just rewrite it. Okay, so it'd be 3 and then x less than or equal to -1. And okay, if a is 3, that'd be 2 times 3, so 6x. And then plus, and then what, b is -3? Well, let's go -3 then. And that would be if -1 less than x less than 1. So if x is between -1 and 1. And then we got -3 if x is greater than or equal to 1. Okay? Now let's evaluate h at 1. So what is h of 1? Okay, where would you plug in 1? Wherever it says equals to 1, or whenever 1 falls in the domain of the parts, right? Does it go in here? No. 1 is not less than -1. Does it go between here? No. How about right here? Yes, what is h of 1? -3. Remember, guys, this is a function. You don't plug this value into all three parts of the piecewise function. Okay? Okay, now we got to figure out the limit. And again, we're asking ourselves, what is the limit as x goes to 1 of h of x? That's what we're asking ourselves. And we're going to find that value in these piecewise functions by looking at the left-hand limit and the right-hand limit and see if they're equal to each other. So what's the limit as x approaches 1 from the left? What part of this piecewise function do we use? Numbers smaller than 1 fall right here, right? Well, Mr. Bonley, these are smaller than 1. Well, closer to 1 than that, okay? So we use this part. So basically, it'd be the limit as x goes to 1 from the left of 6x minus 3. And since this is a nice, neat polynomial, linear function, we can do direct substitution, 6 minus 3, and that gives us 3, right? Okay, that's the limit from the left. Let's see what the limit from the right is. Limit as x goes to 1 from the right of h of x. Number is bigger than 1. What's the limit? -3. Okay, does the limit exist? No. So we can say, therefore, limit as x goes to 1, h of x, dne. However, let's answer the question. Is h continuous then? No. So h is not continuous at x equals 1 because the limit as x goes to 1 h of x does not exist. Okay? This should be everything you show and say for this problem. Is this function continuous at -1? That could be the other question we ask, right? Well, you do the exact same thing. What's h of -1? That's 3. What's the limit as x approaches -1 from the left? That's 3. What about h approaching -1 from the right? Plug in -1 here. That means plugging in -1 here. That makes -9, right? So would this function be continuous at x equals -1? No, because the limit does not exist at -1 again, right? Okay? Are we good? Okay. And again, continuity, these types of problems are going to be asked a lot based on piecewise functions because you have to set up the left and right hand limits. All right, now here's another problem. Here's another piecewise function. Again, get used to seeing piecewise functions. The question will be, what values of a and b, or value of a and b, make the function continuous on its domain, or make the function continuous? So what values of a and b make the function continuous? Make h continuous. Again, remember h and h of x are the same thing. Now this one, well, h is defined at -1. Looks like h is defined at x equals 2. Okay, so h of -1, h of 2 exist. Okay, for this one we have to set up equations and solve. Okay, so a big hint is which one of these processes allows us to set up an equation? The limits. Okay, for the limit to exist, the left-hand limit has to equal the right-hand limit. Okay, so let's check at x equals -1. What's the limit as x goes to -1 of h of x? Well, to do that, we have to figure out we have to show that the limit as x goes to -1 from the left equals the limit as x goes to -1 from the right. Okay? Well, what is the limit as x goes to -1 from the left? That's just 4. What is the limit as x goes to -1 from the right? ax plus b. However, I maybe should talk about what is x going to be though. In this situation, what's x?
-1.
-1. So we should write this with x being substituted in. So that'd be -a plus b. Are we okay at saying that right away? Put the negative in front. Well, Mr. Bond, I can't solve for this. I got 2 variables. Well, you guys have taken algebra 2 and algebra 1 before. How many equations do you need if you need to solve for 2 variables? You need 2 equations, right? You can use substitution, elimination, or the graph method. For us, it's always going to be substitution or elimination for solving for these, because there'll probably be no calculator problem anyways. So we need to come up with another equation. Guess what we're going to do? Find the limit at 2 then. Okay. So I'm going to skip a step here and not write the first part. We're just going to set up the second part, not h. We're going to find the limit as x goes to 2 from the left. That has to be equal to the limit as x goes to 2 from the right. The limit as x goes to 2 from the left, that'd be ax plus b. And the limit as x goes to 2 from the right, that'd be -4. Now, if you're confused why x equals 2 here, check this out. I'm just going to write it up here, though. That'd be the limit as x goes to 2 from the left of ax plus b, right? And then you substitute 2 in, so we can do that. That's why we're making this x2. So 2a plus b equals -4. At this point, you got two equations, two variables. It's up to you what you want to do. You want to do substitution or you want to do elimination? Well, elimination includes substitution anyway, so you're going to do substitution sometime. But it's up to you. What do you guys want to do, elimination or substitution? Substitution? Okay, what variable you want to solve for? With what equation? Right one. Then what? The left one into the right one? So what do you want to solve for in the left equation? You want to solve for A?
Oh yeah, we're solving for B.
Solve for B? Add A over here. A plus 4. I mean, it's your problem. Do what you want to do. If you want to do it differently than I'm doing right now, go ahead. You want to do elimination? Check our work. Okay, now what do we have to do? Substitute this in the other equation. So then we'd have 2a plus a plus 4 equals -4. So 3a equals, I'm going to subtract 4 in one step also, so that'd be what, -8? A equals -8/3. Are we okay with that? Okay. Now we got to substitute this back in somewhere to solve for b. Where's the best place to do that? There's the best place, and there's a couple other places we could do this too. Right? You want to go right here?
Yeah.
Okay. 4 equals negative makes positive. Was that 8/3 plus b? Oh crap, we got a fraction. I don't like fractions. How could I clear fractions if I wanted to? Where? Everywhere, both sides. That'll clear the fraction, or we call killing the fraction. 12 equals 8 plus 3b. Subtract 8, and you get 4 equals 3b. Then b equals 4/3. Mr. Bonley, can we get fractions? Is a fraction a number, guys? Yes, you can get fractions, that's fine. Where would have been the easiest place to substitute a back in? The place where b is already isolated, probably.
I just want to make it positive.
That's okay. I like the attitude. It's good. Positive attitude. It's Friday, right?
Yeah.
Good. Okay. All right. Again, there's many ways to take care of this problem. First period, I made him do elimination at the very beginning, so we had to multiply this equation by 2. So that we had a -2a and a positive 2a, so you could add the two equations, right? Remember doing that? So that works too. Questions on this? So what does this mean? That means if a is -8/3 and b is 4/3, this function lines up with this function, which then lines up with this function. So it's continuous everywhere. Okay? Basically it's like, okay, at 4, then we go like this, then we go like this. That's basically what's going to happen. Yeah.
Shouldn't 8/3 be negative and the 4 equals
Right here?
8/3 at the bottom?
We did negative.
Oh yeah.
Whew. Questions on this? I think these problems seem extremely intimidating at first. You don't know what to do, but remember, we're studying limits. And how can you work with limits in these problems? Set up a limit equation. That's the basis of this being true. Okay? Homework? Do we have, huh?
On Friday?
Huh.